Hello everyone. We have learned already in the last video how to test the outcome of an estimation problem in an overall manner using the so-called overall model test. In this video, we will go in depth and interpret the overall model test and specifically what the source of the rejection is when a model is rejected. We will also briefly discuss and give an outlook of what can be done in case of the rejection of overall model test. However, note that the detailed systematic treatment of model rejection is beyond the scope of this course. So let's start with our now famous mathematical model consisting of functional and stochastic parts and the equation for the blue estimator and its residuals. Now let's look at the overall model test statistic. We already saw that this test statistic has a chi-square distribution with m-n degrees of freedom. And we discussed that if the t-value is below a chosen threshold, the test is rejected. Now the question is, if the test is rejected, what can be the source of the rejection? To answer this question, let's look in more details to the test statistic. We can write t in this form. We see that the test statistic is a function of four components: observations, matrix A, x hat, and the covariance matrix Q. I can even insert the full equation of the x hat in this equation and derive this long expression of test statistics. Here we can already see that the t parameter is a function of three components in the mathematical model: observation vector, design matrix, and Q. We can say that if the overall model test is rejected, the problem is in the mathematical model. And by the problem being in the mathematical model, we mean it is in one of these three components. 1. There may be something wrong in the observation vector y. The most obvious problem is that we may have some outliers in the observations. There may be a problem in the design matrix A. That is, maybe our functional model is not correct. And the third option is maybe our assumed covariance matrix is not correct, or it cannot sufficiently describe the uncertainty in the data and the statistical properties of the random errors involved. In summary, if the overall model test is rejected, it means the mathematical model is wrong. Which part of the mathematical model is wrong, we don't know yet. Let's look at some exercises and then continue this discussion in more details in the next video.